Recently, a group of astronomers and researchers from NANOGrav Physics Frontier Center have identified a massive neutron star named J0740+6620. This pulsar also happens to be the largest one ever discovered. It has a mass of 2.17 of our suns, crushed down to just 30 kilometers across. Pulsars form when a massive star like a red giant runs out of fuel. Yes, stars use fuel. A star will always be at risk of collapsing under its own gravitational pull. However, because the gravitational force is so strong, it causes elements inside the star to fuse. This fusion process begins with hydrogen. As the elements fuse and create heavier elements, the heavier elements fuse. The star keeps this balance up until the fusion process can no longer continue. This happens when elements fuse down to iron. Iron does not fuse and no longer produces an outward energy. This means that the gravitational pull wins and the star's own weight causes it to collapse on itself. All the mass of the star is being compressed into a small solar body. This causes a huge stellar explosion to occur. All that remains after the explosion is either a black hole or, in this case, a neutron star. Depending on the mass of the star, either could be produced. Neutron stars have a lower density than black holes. However, they still have over 200 billion times the gravitational pull of Earth, and are the strongest non-black hole solar bodies in the universe. There is a difference between neutron stars and pulsars. Pulsars are neutron stars that rotate at extreme speeds, sometimes over 70,000 kilometers per second. Due to the rotation, pulsars emit a jet of electromagnetic radiation. Sometimes pulsars can be viewed from Earth, and the spinning appears to look like a pulsing. In this case, the researchers and astronomers have found a white dwarf in front of the pulsar. According to the astronomers, the pulsar is passing behind the white dwarf. Astronomers can use the pulsar's pulsing as a method of finding the mass of the white dwarf in front of the pulsar. This method is called the Shapiro delay. It uses Einstein's theory of relativity to prove that the white dwarf's gravity does warp spacetime. This means that the neutron star's pulses have to travel a tiny bit farther to reach us. Astronomers can use this delay to calculate the mass of the white dwarf. After they calculate the white dwarf's mass, they can calculate the pulsar's mass. Information like this can help researchers and astronomers come closer to understanding the complexity of these interstellar bodies.